We're looking at 424, not revealing any new ways of solving, just asking the class to solve this given a 5-minute time period. Anybody got an answer yet? It's good. How'd you get that?
The formula for the ERR. The future word over the present word raised to the number of times, one of the number of time periods.
Good. Did y'all hear that? You use the ERR formula to find that, because we have a present value of $6 and we have a future value of $15, and you use the ERR to find the rate, and that's right. I will show you how I would do it in Excel. Excel has this really cool function. Equals the rate. Can you see the parameters listed underneath, what it needs to calculate a rate? It needs the number of periods, a payment value if there is one, a present value, and potentially a future value. And it will give you the rate that makes that statement true. So what do we know? We know the number of periods was from 2000 to 2006. So there's 6 years there. Was there a payment involved in there? It's 8 o'clock in the morning. This is a bad idea. There's no payment in there. There was a present value and a future value. Yes?
Can you make that a little bit bigger?
For some reason, no.
Yeah, you need to put
Say again?
you need to have a box.
No,
No.
you're supposed to say,
No, thank you. All right, so 6-year period, there's no payment. We know what a payment is. We define payment. We will in a minute then. And what was the present value? 6. Putting in -6. I'll explain why in a second, and it's critical that you do that. And is there a future value? Again? 15, excellent. Give myself a couple more digits of precision. You came up with 16.49, I came up with 16.5, that's well within the range that I would expect. That's using the rate function. And that'll work for everything. So all of these functions I'm going to show you, the present value will almost always be negative. So there's something you need to remember, and let's cover why. If you were there at the very beginning orientation, I talked about the point of view of cash, whether it's coming from you or coming to you, positive or negative. This is how Excel views these functions. They think of present value as something that's being deposited or being invested, which means that money's coming out of your pocket and going away from you. That's how Excel views this, and if it doesn't get that value, it's not sure how to interpret it. So it expects that present value is a negative value. It's not necessarily an expense, but that's how Excel views it. So you'll need to remember that for using that. Does that make sense? So let's verify that. If we had in year 2000, and it was $6, and we're increasing by 16.5% per year, then I should have, if I take this down to 2006, I should be able to say this is this times 1 plus that, right? If I drag that down, I probably need to make that guy not move. If I drag that down, in 2006 I have 15. So we verified that that is the correct answer. Agreed? All right. Rate function seems pretty simple. Comes in handy. All right, how about 4-42? Give you a second to read it, and I'll explain it. So with any purchase, I need to make sure it's worth my while. So let's take interest out of the equation. I buy something for $100,000. It's going to last for 5 years, and it's going to make me $10,000 a year. No interest, simple calculation. Is this a good idea or not? Spend $100,000 to make $10,000 a year for 5 years. No. I'm spending $100, I'm getting back $50 at no interest. So that's the basis of this question, yes. 442. That's the basis of this question. They're looking at investing $10 million. The software, the software is only going to last for 4 years. So what do we have to make or save per year to make it worthwhile? You know how to solve it? worded differently, but it's very similar to problems you've already had. And go. Hint on how to solve? Yes? What is it you're looking for? Can you put it into words what you're trying to find? Okay, really close. We already know the interest rate is 15%, because that's given in the question. So, but you're on the right track. We need to know where these revenues or savings are equal to or greater than our expense. Not necessarily the future worth, though. It could be the present worth of the revenue, because you already have the present worth of the expense. But both would work. So, and those savings are equal per year. So how do we define that? What's the term we use for something that has a consistent time period and a consistent value? Annuity, excellent. Another word for? Any of you have a loan on anything? Is that payment the same every month after month, until you die? Payment is the other word. They are synonymous, annuity and payment. So you're looking for the payment value or annuity value for those 4 years. And with interest, that needs to be greater than $10 million that you spent. So the old way of solving that guy. Where X is your payment value and the represent the interest in years 1, 2, 3, 4. Does that look familiar? Was that fun doing it that way? Yeah. And this here, basic cash flow. There's at year 0, that's my expense, and then I have revenues of X for years 1, 2, 3, and 4. So what I'm looking for is the payment value that's greater than $1 million, right? Or excuse me, then 10 million over 4 years at 15%. So wouldn't it be cool if I had a function in Excel called payment, abbreviated PMT? Oh my God, I've got one. It's crazy. What do I need? I need the rate. Here's my MAR. I need the number of periods. Software's going to last for 4 years. I've got to make my money back in 4. Was there a present value? Yes, there was. That's what we spent on it, 10 million. Is there a future value in this problem? Didn't give one. Notice the brackets around FV. Anything in a bracket is optional value. If you have it, you can use it. If you don't need to. The others are not optional. If you don't have a value for it, you can put a 0, or you can just double comma and skip it. So that should give me 35 million.
Can you back that?
I must have put in 100 million here because that seems really, really large. Let's see if we can type this again. 10. There we go. 3 million. Yes, I'll go back and show you the formula again. So that is the payment value. That's exactly what we would expect to save in years 1, 2, 3, and 4. That plus our interest makes that investment worthwhile. If we're not going to save at least that much, then it's not worthwhile. So a sample question on the final could be something similar to this, where I would ask you, what's the payment value of this? And then I might ask you, is this a good idea or not? So you'll have to use those analytical minds to decide if this is good or bad. Remember, everything in this class is all about money. You want to make as much as you can, yay capitalism, or not lose as little as possible. Good? All right, the formula again was equals PMT. I'm actually bring it up again. Equals PMT. And as soon as you type in your open parentheses, that list of parameters will come up. It's just as simple as plugging in those values. And remember, that present value was negative. Plug it in is not negative. Actually, in this case, I think if you plug it in as not negative, you'll get a negative value back. It's still the same value. But if it's coupled with another calculation, that can screw you up. Yes?
Could you remind us what would make it a good payment or not?
I want to make money. I'm willing to put $10 million in to this software. I'm only willing to do that if that's going to make me money, right? So what we've just calculated is what's the equivalent of $10 million over a 4-year period at 15%. So this is what I have to make every year to make that $10 million worthwhile. So for this one, there's no way that you can answer if it's a good idea or not, because I didn't tell you what our estimated savings are going to be. But if I had reworded the question and said, estimated savings are $2.5 billion per year. Now, how would you answer the question?
It's not worth it.
Excellent. It's not worth it. I need to save 3.5. My estimate is 2.5. That's $1 million loss per year. I do not want to lose $1 million a year. And if you come to me and give me that suggestion, and you cost me $1 million, I will fire you on the spot. You don't want to be fired. You want to keep your job. You want to make your boss happy. That's what all this is about. This exercise in futility we call education is just so you can get a job. It's not really an exercise in futility. But. All right, we good on payment? So, yes?
Wouldn't there be another use for this? Or is it mostly for annuities that we're using?
Oh my God, this is probably the most useful function in your life. Were you there at the orientation when I talked about that truck that I bought that cost me like 3 times what it should have? Yeah. I recently bought myself a graduation present. Bought a new BMW convertible, and I roll like that. It's used, so new to me anyway. When I went to the finance company, they threw a payment number at me, and I shook my head and said, "That's not right. You've made a mistake." And of course, he was indignant and like, "Dude, I know what I'm talking about. This is wrong." I know that because I knew what I was paying for the car, and I knew what the rate was, and I knew that I was only going to pay for 36 months, and I can plug that in. So, well, let's just do it, shall we? 8% was the rate. The number of periods was 36. And the present value is what I paid for the car. I don't care if you guys know that. And there is no future value, right? Now that's 36 months, and that's 8% per year. My rate and my period doesn't match, right? If I'm talking months, my rate needs to be in months. So what's 8 divided by 12? Is that 0.66? No, your payments are monthly. If the payment value is what dictates. If that's monthly, you need to get the rate in monthly. So I think it's 8 over 12, I think it's 0.66.
Could you just do 8 over 12, like, in parentheses? In the first percent?
You want to do 8 over 12? Like that?
Yeah, except for 12, not 16.
Well, I tell you what, let's be safe. Let's go over here. And we'll go rate. And that equals 8 over 12. Good? And there's no future value. And present value should have been negative. There it is. There's a monthly payment. So, insight into my life, my personal private finances that are now up on YouTube. So,
Along with your handsome face.
yeah. So when he told me the payment was 6 and some change, I said, "Excuse me?" Now that's only, it's only like $30 difference, but that's my $30, and that's my $30 per month for 36 months. So they had this hidden finance fee in there that they weren't telling me. It was disclosed somewhere in there in the fine print. But my knowledge of engineering economics helped me to know exactly what I should have been paying. And when he handed me a contract that said something different, I handed it back. He said, "You're either going to make this right or not make the sale. I don't give a shit either way." I'm sorry, I don't give a poop either way, YouTube fans. So that's one practical use of this. In a business sense, when you convert a project into an annual value, we're looking to see what do we stand to make on a consistent basis over time. We know that things are going to fluctuate, but sometimes it's valuable to look at what is this thing going to do for us over the course of the 10-year life of the project. Does that answer your question? All right. We're good on payment? I can guarantee you this. There will be a question on the final that you can do either way. There will be a question where you have to find the payment value. And you can go ahead and calculate it the old, tired, tedious way, or you can do it this new, wonderful, fabulous way. Choice is yours. Either way, you're going to come up with the right answer. Good? How about 461? So we're moving so well. I'd like the future equivalent. I'd like answer A from this. How would you solve this? Anybody? Let's break down the thought process. What do you know? Again? Payment and interest, excellent. Payment is how much? Good. Interest is? Excellent. So we know the rate is 6%, and we know our payment value is $2,000. And we know that a payment is a consistent value over a consistent time period, right? Which means it happens every single year. So next question, how many years are we talking? That's a tricky one. Y'all see why I got 40 years and not 39? To count the number of years when you're dealing with payments, you count the number of payments. And it looks like our first one starts on our 26th birthday and ends on our 65th birthday. So it's 65 minus 26, including 26. So, and that tricks a lot of people up. And I can hear it already. I only missed it by a year. Can I have a re-grade request? What's my answer going to be?
Yes.
Really? You don't know what my answer is going to be? It'll be no. You need to know how to calculate the years. So that's 40 cells that we're going to have to drag down through Excel. We like that idea? Think there might be a better way? What formula might I have in Excel that would help me solve this problem?
You try.
Oh, who said that? Nicely done. How do I use it? How do I use the future value formula? Equals FV. Well, you guys don't need me at all. Cookie, you trained him well. Equals FV. Not VF, FV. And again, the parameters show up. My rate was 6%. Number of periods we said was 40. Payment, positive or negative here? Which direction is the money going from you? Away or to you? Away. How do we define away? Positive or negative? Say again? Negative. Negative 2,000. Excellent. Do we have a present value? Did we start with something in there? No. We didn't say we had an initial deposit, so we have no present value. That's it. That's all there was to that. I didn't need 40 cells to drag through. I needed one cell. As far as showing work for the final, what I would expect is that you would say my rate is this, my payment is this, my end value is this. You show me those three values and then a calculated cell and you're golden. And you're done. You'll walk out of this final in 25 that it's flat. But, so we've covered payment, rate, future value, and payment and annuity, same thing. So what type of formula have we not covered? Present value. Based on what you've seen, what do you think the present value formula might be? Huh? Equals PV? You guys are on it. Jacques was tasked. Say again? Part B. Excellent question. Let's do that. So we're going to start making annual draws. How many of them do we want to make? How many? Yeah. So we're going to need to cover 20 years of living. God, I hope that's incorrect. So, you tell me how we would solve that. What are your thoughts on it? Okay? Ignoring the first part. If I said, you know, I want to withdraw a certain amount of money every year for 20 years, what information would you need to know? Okay? That's what we're trying to find out. Do we know how much we have to start from? Yeah, now we're not ignoring the first part. Yeah. Because we need that value. That tells us how much we're starting from. On my 65th birthday, I have $309,000. So that is my present value if I were to step forward in time some indeterminate number of years until I'm 65. Now, it's crazy how far away that number seemed when I was sitting in your seat, and now I'm thinking, that's not that far. It's still kind of far, but anyway, this is the present value if I step forward in time to my 65th birthday. So this present value is times 0 on my 65th birthday. And I want to start withdrawing 1 year later. So 66 through 85. And a withdrawal is what? What type of value is that? What? It can be positive because it's coming to me, but what's the word I'm looking for? A what? A payment. We have a formula for that, right? Yes, we do. So I want to know what's the payment value. Again, I think we said it's 6%, right? And it's going to be over 20 years. And my present value is the negative of that cell. That's my present value at 65. So I can withdraw $26,000, almost $27,000 a year. All right, so real life question. Is that enough? Is $26,000 a year enough to live on in retirement? Everyone agrees no, right? What is enough? How many ISC majors are in here? Civil or construction engineering? What else we got? BIT? EE?
Materials.
Materials? Starting salary, what do you guys figure? Somewhere in the 60s, is that rough? Okay. So ideally, it'd be nice if you retire with roughly your current salary. It doesn't always happen, but that's a good number to shoot for. So let's say that you need to withdraw $60,000 a year over those 20 years that you're going to live. How much do you need to start with? let's redo this problem, let's work backwards and find out. We're going to go all the way back and figure out what we need to put away every year to meet our goal. So let's start with, we wanted to draw $60,000 a year over 20 years. How much do I need to put in the bank on my 65th birthday to make that happen? Using your Excel function that you've just been shown, you can find the present value given number of periods, interest rate, and a payment amount. And I've just given you all three of those. 6%, 20, and 60,000. Say again? Negative. Excel looks at that as this is how much you're going to have to deposit in the bank on your 65th birthday in order to have a positive withdrawal of $60,000 a year. That's why I came up negative, yes.
So when you put it into the function, you had the payment as positive?
Payment I left is positive because this is a withdrawal. This is money coming to me, not money that I am depositing. And that gave me back a negative value, which tells me this is how much I have to put in the bank on my 65th birthday. So now let's take that money. Is that dollar value a present value or a future value relative to my 26th birthday? Future. And why am I using 26 now instead of 65? Right. Because what I'm trying to do is work backwards and figure out what do I have to invest every year to meet this goal at 65. So what function am I going to use? Here. I like it. So let's take that value. Let's find the payment at 6%. For how many years? 40, good. Is there a present value? I didn't start with anything. Is there a future value? Yes, there is. Now, my future value, Excel is going to expect to be positive. So even though this is a negative value for my present value at 65, I need to make it a future, positive future value. That tells me that if I invest $4,446 every year for 40 years, then I will meet my goal. So is that an attainable goal at a roughly $60,000 a year salary?